In these slides, I'll review exam 2. You'll see that each slide has at the most 2 problems, 1 to 2. Some of the multiple choice that don't have any work to the problems, I have 2 on each. So you don't have to spend time watching each slide. You can just skip to the slides where you had problems on the test and watch those. This slide, the first question, which of the following descriptions most accurately reflects the risk position of a fixed mortgage lender in comparison to a adjustable rate lender? A fixed mortgage lender would have a higher interest rate risk, but a lower default rate risk, which we see is C. Here we have a series of loans. Loan 2 would be the fixed rate mortgage because we see here that it doesn't adjust at all. Loan 1 would be a adjustable rate where there are no caps. Loan 3 is an adjustable rate with a 1% cap per year, and Loan 4 an adjustable rate with a 3% cap per year. Otherwise, they're the same, in that they're a 20-year loan maturity, and the points are all 1 point. So which loan would have the second lowest initial interest rate? Okay, so you'd say we have the lowest interest rate, so we're talking about where the risk would lie here. So the one that should have the lowest interest rate would be the one that has the most risk, which would be Loan 1. Okay, it has it's adjustable and there's no caps. So every year it can adjust to whatever, 3% up, 5% up, 7% up. The next riskiest, so I would say we should have the second lowest initial rate, would be the adjustable, but there's a 3-year cap. Okay, because it would be safer if you had a 1-year cap, and it would be even safer if it was a fixed. Okay, so that adjustable with a 3-year cap is Loan 4. Then question 3, in which loan does the borrower have the second lowest interest rate risk? So here we're saying the borrower has the second lowest interest rate risk. So we're looking at the risk to the borrower. So if they have a fixed rate, then they have the lowest interest rate risk because it's not going to change at all. The next would be Loan 3, where it does adjust, but it's capped out that the most it could change in any 1 year is 1%, and that is Loan 3. Loan 4 would be riskier because it could adjust up to 3%, and Loan 1 would be even riskier because it could adjust up to any amount. This question, under which scenario is negative amortization likely to occur? Well, first of all, we have to have a payment cap, so it would have to be A or C. And also, even if we had a payment cap but rates were decreasing, we wouldn't likely get negative amortization. So we'd have a payment cap and rates increasing, which is A. This problem is one of our incremental problems. First of all, the borrower is purchasing a property for $560,000 and can choose between 2 possible loan alternatives. The first is a 80% loan for 30 years at 6%. So we see 80% of 560 is $448,000. Or a 90% loan for 25 years at 6.25% and 1.5 points. So 90% of the 560 is 504. And now we're assuming the loan will be repaid in 5 years. What's the incremental cost of borrowing the extra money? So although one of the loans is 30 years and one of the loans is 25 years, since we only are assuming to keep it for 5 years, that part really isn't an issue at this point. It is an issue when we calculate the payment, though. So we see we need to get what in the 80% loan, we look down below at the bottom of this. The 80% loan, $448,000, but we're only going to receive 99% because we have to pay 1 point, or $443,520. The 90% loan, we're going to receive 98.5%, so we have to pay 1.5 points. So 504 times 0.985, 496,440. Okay, and the difference between those two amounts, the amount we borrowed less the points, is $52,920. That's going to be our present value. Okay. Now we have to calculate the payment for each. Now on the 80% loan, the present value will be $448,000. It will be for 30 years at 6%. Future value 0, and we calculate a payment then of $2,685.99. For the 90% loan, the present value will be $504 for 25 years, so N will be 25 times 12. The interest rate, 6.25 divided by 12. The future value, of course, is 0, and we compute the payment, $3,324.73. Now, the difference between these payments is the incremental amount, and that's $638.74. And then finally, since we are paying this off in 5 years, we need to find the balance of each of these loans after 5 years. So for the 80% loan, we know we have a payment of $2,685.99, and we would be receiving 25 more years of that payment at 6%, the future value of 0. So we compute that present value and we get $416,884.08. And then for the 90% loan, we'd get $3,324.73 for 20 more years at 6.25 divided by 12, and the future value 0, and we compute the present value there, and that's $454,864.10. So the difference between the balances in the 5th year are $37,980. Okay, so we have our present value. See at the bottom our final calculation. The present value, the difference between the amounts we actually would receive when we borrow, $52,920. N is 60 because it's 5 years. 5 times 12 is 60. The future value, the amount we'll have to pay off, the incremental amount, $37,980.10. And then the payment, the incremental payment, $638.74. And we compute that interest rate, multiply it times 12 to get an annual rate, and we see that it's 10.12%, or B. Problem 6, in this case, we're looking for the effective cost of refinancing. Okay, and they're saying the origination fees and closing costs are $3,500, and the closing costs are not financed by the lender. Okay, so the first thing we have to do is say, all right, what would be, the borrower made a mortgage loan 5 years ago for $285,000 at 8.25 for 30 years. So we'd say, what would have been the payment on that loan? Because we need to have what's the balance right now, 5 years later, when we want to refinance. So we find the payment. We use the amount we borrowed, $285,000 as our present value, our current rate, 8.25 divided by 12. The term is 30 years, so 360, fully amortizing, so the future value is 0, and we calculate a payment of $2,141.11. Now we use that payment to find out the balance of the loan after 5 years, so what we would have to refinance. So the interest rate at 8.25. Now there would only be, since 5 years would have gone by, 300 payments left, future value 0. We know the payment, $2,141.11, and we calculate the present value, so or the balance at the end of the 5th year, $271,559.34. Now we take that, say that's the amount we'd have to borrow. So we want to borrow exactly what we need to refinance. So that's our present value. This is step 3, the $271,559.34. And we're going to continue that for the rest of the 25 years, 30 payments. And the new rate we could borrow at would be 7%. So 7 divided by 12, future value 0, and we compute the new payment would be $1,919.32. But we can't make a decision based on this because we still would have to come up with the $3,500 of closing costs. So we have to find the effective cost and then find out, is that effective cost less than what we're paying now? So to do that, we have to take, this is just step 4, the 271, 559.34, subtract out those closing costs, $3,500, and make the present value $268,059.34. Okay, the payment $1,919.32, the future value is 0, n is 30, and now we compute the interest rate. Again, multiply it times 12 to get the annual rate, and we see the effective cost of this new loan, borrowing just what we need to cover the loan balance, pay out the loan balance, and borrow the same amount, and come up with, out of our own pocket, $3,500 in closing costs. The effective cost would be 7.14%, which is still over a full percent less than what we're currently paying of 8.25%. So yes, we should refinance. This is a market value problem, number 7. This is exactly the same process as finding out what the balance of a loan is at a certain point in time. The only difference is when we discount back the present value of all those future payments, we use whatever the market rate is. So let's look at this problem. A loan is made 15 years ago, $260,000 at 5.5% for 30 years. Okay, rates are currently 7.25%. What's the market rate of the loan? So the first thing we have to do is find out, well, what was the payment of the old loan? So we borrowed $260,000 at 5.5 divided by 12. It was for 30-year term, so $360, fully amortizing, future value 0, and we compute the payment, $1,476.25. Now, if someone wanted to buy this from us, so they want to know what the market value is, basically what they'd be getting is 180 payments of $1,476.25, because there are 15 years left, and that's the contractual payment. But they want to get a 7.5% return. So we take that payment, $1,476.25, 180 of them, n is 180. At the end, there'll be nothing else to pay off, so the future value is 0, and we discount it at the market rate, 7.25, that should say, divided by 12, and we end up getting a present value of $161,716.51. In this problem, we're looking at a buy down. So saying Mr. Fisher's built several houses and is offering buyers mortgage rates of 5% with a 25-year term when the current rates are 6.25%. Fourth National Bank will provide these loans if Mr. Fisher pays an equivalent amount of upfront to buy down the interest rate. Okay, so let's look specifically at dollar amounts. If the house is sold for $509, percent loan, how much would it cost him to buy down this loan? Well, first of all, the house is $590. We're only borrowing 80%, so $590 times 80% is $472,000. Then we'd have to figure out what the payment is at 5%, borrowing $472,000. What's the payment at 5%, and what's the payment at the market rate, 6.25? So we see that's done in step 2 and 3. The only difference between these two, both cases the present value is $472,000, and is the 300 because it's a 25-year loan. Future value is 0 in both cases, but in step 2, we're using 5, what Mr. Fisher's promising, 5 divided by 12 for the interest rate, and in step 3, we're using the market rate, 6.25 divided by 12. And we get the difference between these two payments is in step 4. We have the payment of $3,113.64 from step 3 with 6.25, and the payment of $2,759.26 from step 2 at 5%. The difference being $354.38. So what Mr. Fisher needs to do is pay the present value of $354.38 300 times, because he'd have to pay this every month for 300 months at the going rate, 6 1/4. Okay, so your payments $354.38, N is 300, future value is 0, the interest rate is 6 1/4 divided by 12, and you compute the payment, and that works out, compute the present value, and that works out to $53,720.85, which the closest answer here is the answer B. It is slightly off. But that was the answer, and I did check everybody's results to see if you were in the ballpark here. But the process is absolutely correct. Okay, you want to find out for a buy down, what's the difference between what, say, the builder is offering, 5% of the payment, and what's the difference of that payment for what the current market is, and then take that incremental dollar amount and discount it back today. Find out what's the present value at the going rate, which in this case is 6 1/4. These two are appraisal questions. Appraisal usually contains 3 approaches to valuation, which is not one of them, and that's the ratio approach. We talked about the market approach, the cost approach, the income approach, but there is no ratio approach. And then we talked about how we would do appraisals. So we'd say this: the subject of an appraisal has 4 bedrooms, but one of the comparables used in the appraisal has only 3. If the adjustment for the 4th bedroom is $5,000, the adjustment would be, so we'd say, well, the comparable house has 3 bedrooms. If it had 4, and the 4th bedroom is worth $5,000, it would have sold for $5,000 more. So we have to do A, increase $5,000 to the comparable selling price. The appraised value, number 11, of a property usually represents, and it's not the actual value, we don't know actually what it is, we don't know what the selling value is when we're appraising it. We're not saying the actual replacement value, although that may be used to estimate what the appraisal is, but what the appraised value of the property represents is the opinion of an appraiser. C. 12. When considering federal income tax treatment for housing, the following is tax deductible. And that's the interest on the mortgage loan. The amount that we amortize on the loan, the amount of principal we pay, that is not. Insurance is not, and none of the above is not correct because the interest on the mortgage loan is deductible. This problem is an effective rent problem. We see that we have a office space, leaves $13 a square foot the first year with a $1 step-up provision for each of the following years. The lease is gross with an expense stop of $465, and they give us the yearly expenses: 4.2, 4.65, and 5 1/4. It's a 3-year lease, and the discount rate's 11%, and we're looking for the effective rent. So what we need to do is find out the cash flow for each of the 3 years. So first year, we get the $13, then we have to pay the expenses of $420, and nothing gets reimbursed because the expense stop is above the $420 at $465. So our cash flow the first year is $880. The second year, we now have our step-up provision, so our rent goes to $14. We have to pay the expenses, which we now estimate to be $465, and we'd still have no reimbursement because $465 is exactly what our expense stop is. So we end up with a cash flow in the second year of $9.35. In the third year, we would step up the rent to $15 a square foot. We would have to pay the expenses of 5 1/4, but here we would get reimbursed the difference between the 5 1/4 and the $465, which is 60 cents. So we get the 15, we subtract out the 5 1/4, but we add in what we'd get reimbursed, the 60 cents, and we get a cash flow in the third year of $10.35. We need to compute what is the present value of these 3 cash flows at our 11% discount rate. We put 11% in as the interest rate, compute the present value, and we get $23.08. Now, the effective rent is just what would be the equal annuity payment, the annual payment that's the same for those 3 years that would equal a present value of $23.08. So we set the present value equal to $23.08, n is equal to 3, future value is 0, 11% still our interest rate, and we compute the payment, and we'd see that it's $9.44. So $9.43, same payment at the end of the first year, second year, and third year. If we took the present value of that at 11%, it would equal $23.08. So that's our effective rent for this lease. Now, referring to this last question, if a tenant were offered a net lease with no steps, what would the effective rent be to this lease? Now, here with a net lease, the tenant would be paying for all expenses. Now, when we had the expense stop, what happens there is the owner has the benefit. So, owner benefits if the expenses go down, but if expenses go up, he passes on that risk. So it's actually better to have a lease with an expense stop than a net lease to the owner. Also, this lease here has no steps. So no way for the rent to increase, no automatic steps and no CPI steps. So again, it is more risky for the tenant, for the owner, because there is no increases built in. So in both cases, since this is riskier to the owner, we would expect then the owner would want higher rent. So it would be higher than question 13 because there is more risk to the owner. For this question, I was really looking that you explained the convention, really took on the conventional insured and uninsured, explained, how to qualify, but mainly look for what's the difference between these two, that the difference is 20% down if you wanted to be uninsured. If you could only put down less than 20%, then you had to have insured, meaning that you had to pay PMI insurance. With an FHA mortgage, looking for the fact that this is federal insurance, although it's not FHA is not a mortgage itself, it is a federal insurance, and that they are focusing on low income, smaller property value. And the VA mortgage, mainly the difference is here that they are focusing on vets. Again, low income, smaller property values, but you do have to be a veteran. Here, in this problem, number 16, we're trying to make sure that we understood how a person would qualify for a mortgage. So we have John Smith wants to obtain a $300,000 mortgage on a piece of property that has an accepted offer of $375,000. John's gross income is $85,000, and he has $75,000 for the down payment. He has other debt obligation of $600 a month, and he estimates his homeowner's insurance will be $500 a year, and his property taxes will be 1% of the property value, and he's considering a 30-year fixed-rate mortgage at 6% with 1 point, or a 30-year interest-only loan at 6.375 with 1 point. Okay, would John qualify for either loan? And again, you had to back up your answer, not simply answer it. And that's on the next page. So you'll see here, first on the left-hand corner, we had to figure out what's the payment of borrowing $300,000, fully amortizing, so the future value is 0 for 30 years, so 360 is N, at 6%, so 6 divided by 12 is our interest rate, and we see the payment would be $1,798.65. With an interest-only loan, which is to the right of that, all we'd have to do is just pay the interest on the $300,000. So the rate is 0.06375 divided by 12 times the $300,000. So all we'd have to pay every month is $1,593.75. Okay. Now, to find out if they qualify, we have to get not only what the payment is for the to the lender, but we also have to get the insurance costs. We saw that was $500 for the year, so $500. We're using monthly payments here, so we have to convert that insurance to a monthly cost. So we take the 500 divided by 12. We see that's 4167. The property tax, I said, would be 1% of the value of the property. The value of the property is 375 times 1. And again, we have to divide that by 12 because we want a monthly property tax. And that's $312.50. That same amount is added both to the fixed rate mortgage and the interest only mortgage, giving us payments of $2,152.82 for the fixed mortgage and $1,947.92 for the interest only. Then they also mentioned that there was debt of other debt of $600 a month. So we add that to both amounts because we want to test, first of all, can they pay for their monthly mortgage payment, their insurance, and their property tax. And then, and also another way we look at it is, can they also cover all of that and any other debt obligations that they have? And they have to cover this with their gross income. We see way up into the far right corner was $85,000 was what they said they made, divided by 12. So the monthly gross income, $7,083.33. So our first calculation for the fixed value would be, can they cover their PPI, okay, their payment, property tax, and insurance. So that's the $2,152 divided by the $7,083, which is 30%, which is greater than 28%. So we'd say, no, they don't qualify because we want 28%. What about with their covering their debt obligations? So now we take the $2,752, and we divide that by the $7,083. We see that's up to almost 39%, which is higher than our 36 for qualifying. So no, we wouldn't qualify for this. It'd be fairly close, but by the strict law, qualifications, it's not a law, but by the strict qualification methods, you would not qualify. Now, we look to the right of that, we see the interest-only qualification. And we see when we take the PPI, the $1,947.92 divided by the $7,083, we get 27.5%, which is less than 28%. So we do qualify under that measurement with the interest only. And then what about with the other debt? We add that in, and we get $25,047 divided by the $7,083, and we get 35.97, which is just barely, but it is under 36%. So again, we qualify. So this would go to show you that person wants to buy this house. Either case, they're borrowing $300,000. The loan rates are fairly close, 6 and 3/8. But to qualify, say they don't have great credit, so that can't override it. So to qualify, they really need to go, in this case, with an interest only rather than a fixed loan. And this last problem is filling in this spreadsheet here. The 10 boxes, I have an adjustable rate loan, 30 years with an initial rate of 6.5. It's for 80% of a $350,000 property. The loan requires 2 points. It's adjustable annually with a 2% annual cap and a 5% lifetime cap. And it's based on the following forward rates, 7, 9, 12, with a margin of 1.5 to be added to this index. The property is expected to be sold at the end of 4 years, and there's no negative amortization. Okay, so before we switch to the next page, let's make sure we know which rates we're going to use. So we're 6.5 the first year. The second year, we see the end of year rate is 7. Add 1.5, we're at 8.5. Okay, and it can go up. The cap is 2% per year, so it can go up to 8.5. So we'd use 8.5. The next year, 9 plus 1.5 makes it 10.5. It can go up from 8.5 to 10.5. That's 2, and that's the cap. So we can go up to the 10.5. The next year, we have 12 plus the 1.5 makes it 13.5. But we can't go up that high. The highest we can go over the lifetime of this is 6.5 plus the 5. So 11.5. We're already at 10.5. So the last year here in this case has to go up to just 11.5 and stay there. So let's look at the rest of this. Okay, so what I've labeled A, the loan amount, That's just a 350,000 times 0.8, because we have to put that, we're borrowing 80%, or 280,000. B, have the payment in the 13th month, so at the beginning of the second year. So we'd have to take the ending balance at the end of that first year, which we see is 276,870.37. So that's what's listed as the balance there at the end of the 12th month. That's our present value. Future value is 0. Now we have only 348 months left, because we had a term of 360, but 12 months have gone by. And we noticed, again, from looking in the last slide, that the rate in the second year will be 8.5%. Divide that by 12, and you compute the payment, and we'll get a payment of $2,145.11. Okay. To get the interest amount for this month, we'd take the 8.5% divided by 12 times that outstanding balance, the 870.37, which gives us an interest amount of $1,961.17. Then the difference between the payment and the interest, okay, so the payment was $2,145.11 minus the interest, $1,961.17, is $183.94, and that would go where it's labeled D, the amount that we'd amortize. And then the new balance would be the previous year's balance, $276,870.37, minus the amortization amount, $183.94, bringing us to a balance at the end of the 13th month of $276,686.43. Okay? Now we skip down to the next one they ask us is F. Okay, and F is the interest payment. Well, we know for the 26 months, we know what the payment is, the full payment is $2,538.46, and we know the amount that amortizes, which is right next to the F, $137.11. So the difference between those two, $2,401.34 must be the amount of interest. Okay, we could also figure that out by going above and G first. Okay, with G we need to find out what's the balance at the end of the 25th month. Well, we could just say, well, if we took the balance at the end of the 26th month and added back the amount we amortized in the 26th month, the $137.11, we must get what would have been the balance at the end of the 25th month, where G is. That's $274,439.05. Okay. If we had done that one first, we could have then multiplied that times the interest rate in that third year, which is 10.5 divided by 12, and also arrives at the interest amount in that manner. Okay. In H, which is the next one we're looking for, we need that very last payment in the 48th month. Well, for this case, it doesn't matter. We just need to use the balance at the end of the 36th month, because the payment is same from 37th month to the 48th month. So our present value is $272,863.05, which is just the balance at the end of the 36th month. Future value 0. We now only have 324 months left, because we had 360, but at that point we would have had 36 months go by. And the interest rate in that final year is 11.5%. So we divide that by 12, we compute the payment, and we get $2,739.57. Now we also need what is the final balance. So the final balance would say, well, we know the payment, $2,739.57. So we could say, well, we could just then say it's the present value of all those payments for the number of periods left, which is 312 at the 11.5%. And that gives us a balance at the end of the 48th month of $271,286.48. Okay. There's only two others left. Actually, one other left. We did get the loan amount. There really is only one other left, which is the IRR, okay, which is in what I've labeled up here, Part J. Okay, so we need the cash flow at time 0. So we have a loan amount of $280,000, but there's 2 points. So we have to take the $280,000 times 0.98. We only get 98% of it. And that gives us our cash flow at time 0 up there of $274,400. Okay, and that is just cash flow at time 0. Then cash flow at time 1 is just the payment for the first 12 months, which was already given to us, $1,769.79. We get that for 12 periods, 12 months. Then we calculated the period for time 13 to 24, $2,145.11. Okay, that's the cash flow at time 2. And again, we get that 12 months. Frequency is 12. The third, they gave it to us, $2,538.46. Again, for 12 months. The frequency is 12. And then the last payment we calculated down there in H, $2,739.57. Now that one, though, we're only going to say we get for a frequency of 11, okay? Because that final 12th payment is going to be the cash flow at time 5, which is part of it. It's $2,739.57, the regular monthly payment. But to that, we have to add the ending balance of $2,071,286.48. So the cash flow at time 5, $2,074,026.05. And that just happens once. Okay, so that final payment, that cash flow, the $274,000 is made up of the regular monthly payment of the $2,739 plus paying off the balance of the $271,286. Okay, and then we just solve for the internal rate of return, multiply times 12, and we see that it's $9.64%.